Okay, so in this video, we'll be looking at a very interesting continued radical. This one, root 2 plus root 2 plus root 2, plus dot dot dot, and we'll be seeing why this radical in fact is equal to 2. Now, a common way that you might know to justify this would be using this logic. If we have this value, well, this has to be equal to adding, oops, sorry, I forgot the radical here. This must be equal to adding another layer outside, right? So if we were to take the original, and if we just were to add a layer outside, these two expressions have to be the same, as this ellipsis goes on indefinitely. So we can basically say that x, or the expression itself, is equal to adding another layer, or root 2 plus x. Right? And then after solving this, we can easily get that x is equal to 2. Where this checks, because 2 is equal to root 2 plus 2, or root 4, and this checks. But this way is not really satisfying. Right? There's actually a very satisfying way that uses trigonometry to prove this statement, instead of just using this simple strategy. Okay, so for trigonometry, before we look at it, we have to know the half angle formula, which is that if cosine of theta is equal to some value, we can call that value A, then cosine of half theta has to be equal to root 1 plus A over 2, where both the numerator and the denominator is in the radical. Right. Okay. So to explain this, we can start by finding the value of cosine 45. And cosine 45, as we all know, is equal to root 2 over 2. And then we can look at cosine 22.5. Or in here, we can just write this as cosine 45 over 2. And this would be equal to, you take 1 plus cosine 45 over 2, all in square root, which would be, and if you multiply both the top and bottom by 2, you would get that this is equal to 2 plus root 2 over 2, where only the top is in root. Now this looks interesting, right? This looks a little bit similar to our original expression already. Let's go a little further. What about cosine 45 over 4? So cosine 45 over 2, and then divided by 2 again. Well, we would just take the root of 1 plus cosine 45 over 2, and then divide that by 2 again. So this would yield us 1 plus root 2 this, which eventually would just give us this, which looks even closer to our continued fraction. Now, can we say that if we have cosine of 45 over 2 to the nth power, it would all be similar to this? For instance, if we were to have cosine of 45 over 16, would it be this, but instead of having 3 of this, we would just have 5 2's here. Would that be true? Well, yes. We can kind of prove this by, if you like to call it induction, we can kind of think about this proof inductively. So originally, let's let cosine of 45 over 2 to the nth power be A over 2. Now we can find cosine 45 over 2 to the n plus 1 power. And this would be equal to, through our half angle identity, this would be equal to 1 plus A over 2, this thing, over 2. which if we were to multiply both the top and bottom by 2, that would just yield 2 plus a over 4. So 2 plus a over 2. So note that this does fit our definition here. Essentially what we did here is we took the root 2 and then we simply added a 2 outside and took the square root of the whole thing. And here's the exact same. We added 2 outside of the a and then we took the radical of the square root, right? Oh, these are the same thing. Therefore, if we were to have cosine of 45 over 2 to the nth power, this would just be where it's not really that important. For the purposes of solving this problem, it's really not that important how many terms are there. Because what we will do now is we will take the limit of both sides. So originally, we have this. Now we can take the limit of both sides to say that what happens when n approaches infinity. So this side we will have cosine 45 over 2 to the nth power. And on this, the right-hand side, right, in here we will have n equals approaching infinity, but it really doesn't matter that much because there's no n, right? And then the same thing. So this would mean if this thing goes on indefinitely. Okay. So when n approaches infinity, 2 to the n also approaches infinity. So 45 over 2 to the n will approach what number? This will approach 0. And then cosine 0, cosine of something that approaches 0 is going to be 1. Therefore, we can say that this thing is going to be equal to 1. If we put the 2 to that side, we get what we want, which is that the root of 2 plus root 2 plus this discontinued radical is equal to 2, which is exactly what we desired.